So yeah, infrastructure review of the 3033, and please welcome them with a lot of applause.
Hello everyone, this is Rix, my name is Rami. We are the technical part of both the pre-sale and the cash desk team, and we want to show you some interesting things about what we've done during this event and before this event. We will start with the pre-sale. As you know, all of you have got your tickets before the event. We sold no tickets on site this year, so the pre-sale was a very important thing. After we knew that the event will sell out very fast based on the experience from last year. We had, as you probably noticed, a two-stage pre-sale period that we split into a voucher stage and into an open sale. We implemented this voucher system because we wanted to enable all those people who make Congress possible in the first place to be here. This is, of course, the angels, because we need all these angels to build this. But this is also all the other parts of the community that we need here to build this experience. Because we do not personally know all of them, we implemented this replicating voucher system in a way that once you got a voucher and you paid for your ticket, you got another voucher to share with a friend from a different group, from the same group, from anywhere around the world. So we used the airforce of the CCC, the chaos treffs, and hackerspaces all over Europe and outside Europe and other groups to spread those vouchers. On the software side, the pre-sale was running Pretix, an open source ticket sales application based on Python and Django that we originally designed for the smaller MRMCD CCC event. And it is open source and on GitHub, and it has a very flexible plugin-based architecture that enabled us to implement this voucher replication system. The initial hardware that we had it running on is one dedicated server that has an 8-core processor and 32 gigabytes of memory. After the voucher phase, which ended in late October, we went into the open sale in early November. And we split the open sale again into 3 rounds and issued the tickets on 3 different days to enable people who are working shifts or working late or could not access it at some times of the day or some weekdays to enable fair chances for those people. And as you know, in the first period, in the first round, all the tickets have been bought by toasters. And one of the toasters came. Still, we're very sorry that you saw a lot of error messages on that day. The load of the server was over than 400 HTTP requests per second over a period of a few hours, even though the tickets of the first round were all gone in about 13 minutes. To work with that load, which increased in the coming rounds, we implemented a queue system that we used to quickly handle that load without restructuring the whole system. We put a second dedicated server as a reverse proxy in front of the original one and used it to limit the number of people actually accessing the real ticket shop. If you went on the page on that day, you were presented with a page that says join the queue, you press join the queue, you got a queue position like 360 people are in front of you, the position went down over time, and we let like a few tens of people per second into the actual ticket shop to keep the load manageable. We implemented this queue inside Nginx using embedded Lua configuration. And in the second round, you could play Snake on the waiting page. And if you want to embed that Snake game to somewhere else, it's on GitHub as well. And also, we're very thankful that the VOC the video team offered us to share some server resources, and they hosted the static files, CSS, JavaScript, and images for us. And that is the number for one of the days, I guess. It's 20 gigabytes just of that. In the second round, we peaked at more than 1,000 requests per second, which we handled quite well. There were very low error rates on the queue page, and once you got through the end of the queue, you had a very error-less experience in the actual shop. In the third round, we peaked at 3,000 requests per second, and unfortunately, we had a bug in the queue software that led to nobody actually getting a queue position. We had to restart the queue system at 10:15. Nobody had bought a ticket at that time. We announced it like 10 minutes early. The original time was 10 a.m. And from then on, it went like the second sale with a very low error rates. We got some figures from the pre-sale for you that we want to share that might be entertaining. The first one was not that entertaining for us. We got 1,763 support emails from you that we worked through with 4 volunteers on the team. I want to express a special thanks to Martin, who is not even here. Those vouchers replicated, and the longest voucher chain that you built was 15 vouchers long, and we think that is quite a lot, taking into account how long the voucher phase was. And the next is something that we find very interesting. The average payment time it took for a ticket to be paid was 8.6 days, but if you only look at the tickets bought with a voucher, or without a voucher, it's 9.2 days. And if you only look at those with a voucher, it's 6.8 days. So that replicated system was very useful to speed up the payment processing. We are quite disappointed by the next statistics. 20% of you use Gmail to sign up for your ticket. We expect that to get better next year. The second place, the third place is taken by Posteo. We have another one in. And with about 2%, we have domains of CCCDE, subdomains of it, local hackerspaces, and stuff like that. So I think we can improve here. So I'm handing over to Rix for the cache desk on site.
Right, thanks. Right, because just implementing a new pre-sale shop and fancy replicating system was not quite enough for us, and we were a bit bored. We decided to rework the cache desk software itself, which seemed like a good idea at the time. We called the system C6SH. Obviously, the old system was C4SH, and you know version numbers go from 4 to 6 regularly. It's also based on Python and Django, and we will open source it in January once we, remove the last ugly event hacks. Hopefully on GitHub, and I'm sure the nice people at the relevant Twitter accounts will publish that fact in time. The software we implemented does the software that runs actually on the cache desk that you see when you enter the Congress Center, and it also handles back office stuff like figuring out how many wristbands were given out and if the money in the cache desk is actually kind of correct or, in the right ballpark. We handled this event with those 5 cache desks as every year. We had 22 different cache desk angels because it's a bit lower than last year because we actually didn't have that much work this year. And we had 8 troubleshooters, the nice people on the side who were able to help you if you, lost your wristband, lost your ticket, forgot your email address, Stuff like that. Don't ask. We actually peaked at 27 transactions per minute on day one at about, I think, 10 a.m. Yeah, or noon. So that means about 5 transactions per minute per cache desk. So a transaction every 12 seconds, which is really, really good. For reference, last year it was 20 transactions per minute, which is also really good considering that last year we actually sold tickets on site, so there was cache handling involved, which takes a bit longer. And the maximum waiting time in the queue in the building this year was 5 minutes. Again, due to us not handling any sales on site, so everything we had to do regularly was scan the QR code and give you your wristband and off you go. That was about 17 minutes last year, which is also really good for handling money. And the 17 minutes is only considering the time in the active queue. So if you arrived 2 hours early to get a day pass, you waited for 2 hours until we opened. Right, that's about it from us. And thank you for your interest. We'll see you next time, and I'm handing over to Nock now.
All right. Thank you, and a huge welcome to the network review of the 33rd Chaos Communication Congress. But unfortunately, we have to start with an apology. We realized after last year's Congress that our network simply didn't deliver the Fritzbox experience that you deserved. Clearly, we have let you down. So, for this Congress, we went back to the drawing board and didn't stop until we came up with something radically new. Something that will profoundly change the networking experience of the demanding conference attendees. Something in line with our vision.
We realized that networks are the most frequently used internet infrastructure at Congress. After all, we expect our networks to keep us connected to the Facebooks and Yahoos of our peers. We know that everyone can provide you with a connection to your daily digital world, but we are striving for more. As the leading internet provider within the CCC ecosystem, we want to provide you with a remarkable, easy-to-use and highly scalable network from renewable local sources. And we failed to deliver this last year. And here is why. This is the network design we used last year. As you can see, the network is clearly unbalanced. There are crooked lines in there, crooked links. Overall, it's not very nice to look at. The result, of course, was a disappointing experience for you, the user.
So what we have done this year is we have planned the exact same network, but with a new drawing tool. Look at those beautiful orange and blue lines with pleasingly angled links and naturally balanced distribution points. It is amazingly simple and just beautiful to look at. But we didn't stop there.
Ever since we started celebrating the network build-up in Hamburg, we always had a dark fiber from our data center IPHH here into the CCH. But this year, our incredibly professional and amazing engineers found a completely new way to light this fiber. As you can see in this diagram, the fiber is now blue and slightly thicker than last time, which makes it a lot better, of course. And also, it now runs 100 gigabit Ethernet, so that's good.
But that still wasn't enough for us. Deutsche Telekom upped their sponsoring and enabled vectoring on their fiber. So they were able to provide us with an additional 100 gig redundant fiber uplink connection into this building. With this simple and innovative uplink redundancy, we knew we needed to redesign the whole core network infrastructure from the ground up. This year, we distributed the available bandwidth over not one, but two powerful carrier-grade core routers.
But with this groundbreaking approach, we suddenly realized that we exceeded the physical limitations of the building's fiber infrastructure. In other words, we only had multi-mode fiber available, which is orange. Symbol photo. But for 100 gigabit Ethernet, we needed single-mode fiber, which is yellow.
Luckily, during a week-long team outing of our dedicated engineering department, we found a brilliant solution for this complicated issue. We pulled not one, but two new single-mode fibers through the building in order to provide you the network experience that you deserve. Now, with this innovative and strong backbone in place, we identified the second problem in our previous network design.
Some of our users could only connect their equipment to a measly fast Ethernet port. In line with our vision, we can now provide gigabit to all users on all access switches. But there's one more thing. In some places, we were even able to uplink the switches with 10 gigabit fiber connection to the table. And as you can see here, all switches were carefully pre-staged by our safety-aware engineering team.
After having solved all those annoying cable issues, we felt that we were held back by that antiquated concept of wired cabling, and decided that wireless is the future. So, from this point on forward, we put all our energy into reinventing the wireless experience for the advanced Congress attendee. We felt that the old approach of suspending access points from the ceiling was keeping the network too far away from you, the user. So this year, we were finally bringing the network closer to you. In lecture halls 1 and 2, you will now find access points under your seats. But don't worry, in the unlikely case of the loss of connectivity, network cables would automatically be deployed from the ceiling.
So to summarize our efforts, we had 180 gig of total uplink capacity. The peak uplink usage was over 30 gigabits per second, both in and out. We had almost 8,000 Wi-Fi users at peak times, and almost 80% of them were at the 5 gigahertz band. We have 189 access points deployed, 121 access switches with a combined 6,160 ports, and clearly all graphs went up and to the right.
So, in conclusion, we have terribly failed you last year. However, through teamwork and dedication, with the help of an amazing NOC team, a helpful help desk, and with the support of all these lovely companies, we have managed to deliver because, as you can see in this scientific diagram, it went up to 11. Thank you. So we realized that we didn't actually have any facts in this talk. So we have a bit of time for a few questions.
Apparently, we answered all the questions, which is good, quite good.
There's one question there. Sorry?
Please repeat the question.
So the question was which was the new drawing tool we've used, and it's called Inkscape.
So you realize that the two of you will have to give this presentation from now on in perpetuity, right? You're on the hook now. Well done.
Thank you, Niels.
We had Wi-Fi passwords, yes.
So the question was, I assume the question was what were the most popular Wi-Fi passwords, and we did that statistic. It was about the same as last year, so we figured it's not funny anymore. But yeah, that's the same thing. 33C3, foobar, and blah. Yes.
Hi, was it because of you that the CCH was for a moment located in London or Dublin?
So the issue with geolocation is that there are a lot of different services, and some of these services work by looking at the MAC address of the wireless access point, and we use these wireless access points at many different events. For example, at this summer's hacker camp in the UK at EMF camp, and at also previous other events, and so yeah.
Oh, so it's not a feature, it's a bug.
Yeah, that's a bug, but it's hard to solve because these systems are self-learning, but it takes a while. So yeah, you will get located in Hamburg at some point, and also the IP addresses are used everywhere. So yeah, it's unfortunately nothing we can fix.
As an additional feature, the next time you will be at the conference where those access points are used, you will be in Hamburg. So there's that.
Yes.
Okay, so people on the internet are wondering, since Juniper dropped you last year, where did you get the network equipment this year?
Juniper decided to not let us down again, and they have supported us in a great way this year. They gave us all the 100 gig equipment we could ask for, and I think we got 1.2 metric tons of equipment again, so that was really smooth.
How many bandwidth got into cat content?
Well, as you know, we do not do deep packet inspections, but I assume all of the content is cat content. So I think we have time for one more question, if there is one. Sorry? Yeah, what were the IPv6 statistics? I assume it's 5,000% or something, because at one point our monitoring broke, but what was it?
I think the address is for 4 times as long as IPv4.
Yes,
that's a statistic.
No, well, that number is on the public dashboard. So it's dashboard.congress.ccc.de. You should be able to find it there. We didn't include all those graphs because we figured we could use the time for doing a talk without any content, and you have these graphs anyway. Yes.
Did you get any abuse complaints?
So, well, there's the usual amount of automated emails. There were a few that weren't automated, and some were actually about something serious. But it was less than last year. I think there were only 3 calls in total. So yeah, you guys obviously behaved better. All right, I think that...
Just one?
Okay, one more question.
How many...
The question was how many access points crashed, and I don't believe that any access points crashed. Is that correct? Well, yeah, apparently. Well, the access points. We had a few issues with the controller at one point, but that was worked with. So, all right.
Yeah, there was one guy standing.
One very last question.
How many DDoS attacks did you have?
Outgoing 1, incoming. Now, which actually is quite annoying because you really should use the bandwidth for better things than shoot other people on the internet with packets. That's just silly.
Yeah, we don't endorse this kind of behavior. We think it's idiotic and it's similar to running around breaking infrastructure in toilets or something. It's just stupid. Yeah. So please don't do that.
Okay.
All right, we'll hand it over to the VOC now, the lovely people who brought you all the streams and the video recordings.
Okay, thank you.
Henke.
Das Black hier an?
In Fall 2. Ja, hat auch gemacht. Die kriegen auch ein Signal. Du kriegst aber was.
Ja. Ist halt mittlerweile kaputt oder soll man den Laptop eben abstecken?
Es kommt das Signal. Es kommt das Signal. Er hat einen Block.
So it looks like nobody has used this HDMI socket before. Ja.
Oh, come on, they're all doing an awesome job. Just bear with them.
Ich habe keinen DVI-Adapter hier. Nein, nicht den VGA.
So after some little difficulties, let's start. So my name is Andy, I'm from CCC Rock, and
I'm Jenny, I'm also from CCC Rock, and welcome to the infrastructure view of the walk.
So this time the opening actually worked, and we will also see some slides in the future.
So it looks like while our technical stuff worked pretty nice this Congress, now it fails us.
Okay, und
bringt nichts.
Dann haben wir einen DVI-Anschluss. Okay, möchtest du gleich anfangen mit dem Opening? Mit dem Opening-Talk, das ist nicht so ein Twitch.
So while we wait for the slides, I can give you some facts. This time we actually managed to get the opening working right from the start with audio and subtitles. Maybe we see the slide in a few seconds for it.
Ich kann nicht weiter schalten.
Das ist Live-View, da kannst du nicht weiterschalten. Du musst Mirroring wieder öffnen.
Ich weiß. So viel zu dem Thema. Und das Problem ist ja, dass das Internet nicht passt. Also ich kann jetzt halt das mirrorn, aber also ich hätte ans Kabel ran müssen.
Reload mal die Page. Reload mal die Page auf.
Ja, es ist.
Reload die andere Page.
Hab ich schon.
Mach schon mal.
Das Problem ist, dass hier das Video nicht funktioniert. Unten hat es funktioniert.
Ich will doch mal den Stream.
Ja, das haben wir einfach mit dem Folientalk.
Ja.
Hast du ein LAN-Kabel?
Ja, habe ich jetzt.
Weil im WLAN gibt es da gerade so kleine Störungen.
Gerade unten hat es funktioniert, okay.
Ja.
Moment, LAN?
Ich will hier das WLAN.
Okay, so. Nein. So, ich muss die Priorität schauen, das passt.
Ich schätze WLAN einfach aus.
Ja, das ist eine gute Idee.
Reload nochmal.
Ja.
Ihr seid in den falschen Weg!
Ich weiß nicht, ein erstes Podcast.
Könnt ihr machen, ja. Macht das mal. So, da drüben bitte.
Bitte einmal auf den Laptop da drüben schalten. Bitte einmal auf den Laptop da drüben schalten, das Box kommt mal vor. Oder ein anderes Team. So. Warum habe ich hier keinen...
All right, so I guess I'm jumping in with the GSM, some GSM stats. Meanwhile. So we have a sad GSM spectrum situation. We've run a test network that was very helpful for several years at Congress, and last year, last year in spring, the Bundesnetzagentur they gave away the last free frequencies, so it's not really possible to apply for a test network license the way we've done before. Last year, we got some help by the operator who acquired this new spectrum, but this year they were using that spectrum, and it was looking pretty bad for a long time. We didn't know if we were going to be able to have a network at all. In the end, we actually did get to loan 5 ARFKINs from Deutsche Telekom. Thanks a lot. I don't know what it took to replan the cell phone network in downtown Hamburg at Christmas to do that, but pretty cool. Unfortunately, it was too late to print any SIM cards with this year's theme. So yeah, sorry about that. And it was also so late that we had not a lot of staff working on this. But we managed to set up even more BTSs than last year. We had 9 total this year in these locations. 6 of them Sysma BTSs, 3 of them IP access nano BTSs. We'll get back to that in a little bit. And all of this was running in the 18 megahertz band. So we did some careful experiments. Last year, we started using GPRS on 1 of the 8 time slots in each BTS. And this year, we set it up a little bit differently. We activated it yesterday, and with dynamic time slot assignment. So, but however, only on the Sysma BTSs. We'll get back to that in a bit. The configuration was such that depending on whether you were doing calls or the users, you guys were doing calls or wanting to do GPRS packet traffic, the frequencies get allocated differently. So previously, last year, we had a fixed configuration where 1/8 of the available frequency spectrum was used for packet and GPRS. This time, more dynamic, which meant that we had a lot more possible capacity for GPRS, but it ended up not being used so much. We'll get to the numbers right now. We had subscribers, signed on SIM cards, 3,750, so including SIM cards from lots of old events, and sadly only 300 new SIM cards that we had left over from last year. About 1,200 created calls and 400 established calls. So the difference is creating a call is when you dial, and for the established call is someone actually picking up. And you know, there can be lots of reasons for a call not getting established. The phone is the phone you're calling is just not online. There's no free there are no free channels, etc., etc. Text messages, a couple of thousand, 3,200 sent, 2,800 roughly delivered. That's pretty good. Not many that didn't arrive at their destination. And the GPRS numbers are quite a bit lower compared to last year, even though we had 6 times as much potential capacity allocated or dynamically allocated. About a third of down. So actually, I guess this should be swapped. Well, receive on the network side. This is third of the bytes received and a fifth of the bytes transmitted. So you were better at using GPRS last year. Then we have some fun IP access bugs. So this is the nano BTS, the 3 units that I mentioned. They're not completely stable. So especially when we turn on GPRS, they're not completely stable. And I don't know this. So these are some error messages that they send out to the OpenBSC base station controller that we're using. So plain text error messages, and I don't know if someone knows like C or C++ or Java. It's an assert checking that this queue allocated thing is either allocate magic or not allocate magic. So the queue is, I guess, not allocated, but it's also not allocated. I don't know what they've done there. I want to say thanks to the heroes that were running this network, because we got the frequencies so late. Many of the people who have been helping before, they weren't so excited about joining, or they had already made other plans. They did help with setup and teardown, but essentially the operation of this network was done by 3 people, 2 of which who were doing this for the very first time this year. And I want to say thank you to you guys who were using this network, because it helps a lot to find issues and improve the Osmocom software OpenBSC. Thanks.
So in the end, we got it working. Looks like Murphy got us in the end.
Okay, like you already... Like you already told, the opening system was with serial audio, with translations, with subtitles and everything. So, great.
So this year's streaming CDN, we had 17 edge relays, 3 in-house relays. All the Deutsche Telekom customers were directly fed from the 31st C3, and we delivered over 130 terabytes.
So this time we decided to support an additional language, translated language in Hall 2 and 1. With the several codecs and with the Sender Centrum and so on, we got very, very many video feeds which we all had to mirror and so on. Yeah, you know.
Also, this time for the first year, we used MPEG Dash. It was only in a beta test. It worked starting day 2. And there were some FFmpeg extensions, and the patches are incoming.
So actually about... But only about 30 people per day used it, so yeah. But now we know how to do it, and great. We used 10GE everywhere this time. So basically we had 4 10GE boxes, 1 40GE, but we didn't use it to full capacity, so please watch more streams, or we will start producing in 4K.
So here are our statistics for the stream viewers. Here we have the 3 peaks, which is Fefe, methodisch inkorrekt, and the CCC Jahresrückblick.
So actually, more people watched Fefe Jahresrückblick, Peak Fefe than MintCorrect, but MintCorrect had higher bandwidth because there was more movement and yeah.
More stuff flying around.
So we also, at our fifth room at Sendezentrum, we tested our new tele intercom setup based on a Raspberry Pi. So everything with Ethernet, and yeah, worked quite good. And we now have also intercoms for our decentralized events. Yeah, great.
Also, this time for the first time, we used Walk2Mix, which is the software video mixer we developed on the Congress. It was used in Hall 6 and Hall G. And it's on GitHub, so please use it.
And yeah, we were also to finally eliminate Flash. So for the time between the live stream, so the start of the live stream and the publishing of the finalized recording, or the first finalized recording, we have the service called Relive, where you can, yeah, it's basically a stream dump, but provided by us. And for some browsers, we had to use Flash there, because HLS playlists and so on are not natively anywhere. And also on day 2, there was a nice guy which said, hey, here is this JavaScript HLS player, why don't you use it? And our streaming team said, yeah, and great.
Also this year, we, for the first time, had an assembly where you could learn about how C3 Walk operates, about how to use and set up Walk2Mix, and how to build your own C3 Walk, basically, for small events and where we can't go there.
So we had several sessions self-organized about Walk2Mix. Also, the HMI guy had a session there and so on. So we will continue this thing, and it was nice to talk to you. Yeah.
We had an overwhelming interest from the angels. Actually, in the first introduction meeting for the video angels, we basically halfly filled up this hall. There were over 250 angels, and there were about 12 hours work angel shifts per talk.
So each talk, each session in the schedule had a work of 12 hours behind it. Yeah. Like last year in Hall 2 and Hall 1, we had subtitles live subtitles generated by angels inside of the room. It were about 80. You can basically read the numbers yourself. We also added subtitles for this room for methodisch incorrect. And yeah, you see the numbers there. And actually, I think this 507 strokes per minute is quite good.
But there is more help needed because not all of the live subtitles get reused for the releases. So we need your help to subtitle all the talks with all the languages. And if you want to help, go to c3subtitles.de, where you can see how to subtitle the talks.
Yeah, really do that, please. So here you see a screenshot of the interface the angels use to generate the subtitles. Yeah.
There were 6 subtitle angels working simultaneously from Incorrect.
Nearly last slide. So I don't know if you're aware of this Markov bot, which generates random tweets, and we find it quite nice. So all talks will go to media.ccc.de, and the YouTube channel with the same name. Please don't use the other ones. If you subscribe to it, please unsubscribe, and so on. You know it. Just read the blog post from last year about this YouTube problem. And we also have to thank our sponsors because, yeah. Now, is this the wrong window? Ah. So, any questions? Great. So, who's next? And by the way, so this was a live presentation with Wi-Fi, but the Wi-Fi quit when we came on stage, and now we're using UMTS. And this cable is not connected. Why?
So, oh, nice, the microphone works. It's a good thing. That's my slide. Little bit off center, but I think that's fine. Better than no slide at all. So I'm Sebastian from the Seidenstraße team. And this year we also decided that we need to improve your user experience. Because last year we had the field telephones, and you had to call when you wanted to route the capsule, and we had to do most of the routing by hand. And to be honest, that's an hacker congress. We don't call people, we press buttons. So what we did, we added more auto routers. We had 3 of those routers. We had them spread out all over the building. This was also one of the largest installations we did so far, because hey, it's the last time in Hamburg, and we know the building, we know all the secret places where we can sneak the pipes through, and we thought, okay, for the last time, let's use all of it. And it was really ambitious, and we had 1 auto router when we started the setup here, and all the other auto routers were basically built on site with materials that were available. The next thing we need to get across these huge fire doors. So basically, in the elevators, the escalators is the word. The escalators leading from the Sendezentrum up into Hall 1, there's this huge fire door that's retracted in the floor. And we're basically not allowed to cross there with our pipe, because since the door cannot cut the pipe or something like that, and then the door is blocked, and in case of fire, we have a problem. So we decided to build an emergency disconnect, which worked electromagnetically. So in the normal case, the electromagnets had power, and the tube was held in place by electromagnets. And as soon as the power fails, for example, because the door opens and triggers our switch, the electromagnets turn off, and the tube comes crashing down and hopefully hurts no one. And since we had already automatic routers, some people decided we need also an automatic capsule scanner, so that you can send capsules via data matrix codes that you can stick to them. We did not use the scanner here this year. It worked, but we had some trouble connecting it. And I'm going to talk about that in a minute. The other thing we added was we had a new user interface. So instead of field telephones, we wanted to provide you with a keypad. Just type the number where you want to send something to, press enter, wait until the display tells you to stick the capsule in the tube, suction starts, and everything is fine. Yeah, so we thought. The problem was, I basically spent the last 2 months working on parts of the electronic, and there are a lot of custom bus transceivers in there because we use our own bus architecture. And I worked really hard to finish them in time. And since I arrived pretty late here, I decided to send them ahead using DHL. And somehow, DHL seems to be really afraid of us. They sabotaged us. So the parcel with the bus transceivers, there were like 20 bus transceivers, and I had 10 finished in advance and sent them here. And yeah, the 10 bus transceivers arrived yesterday. So next time we better send it with Seidenstraße, it's faster. So in the end, we had to work with what was available, which were like 6 or 7 bus transceivers, which I kept back because they didn't work when I packed the packet, and I had to fix them. So I spent the morning of Christmas soldering in my basement, which was fine by me. I'm not a huge Christmas fan anyway. So let's talk about some numbers. So we had 10 stations. Each station needed a transceiver, so we didn't have enough transceivers for all our stations. First problem. Next problem is each router also needs a transceiver. So we were another 3 transceivers short. We also used 100 meters of tube, so 1 kilometer, which is a bit more than last year, but I don't think it's the most tube we used. We are not quite sure about the numbers because we basically counted the leftover rolls of tube, and then we ask ourselves how much tube did we order in the beginning, and was there anything left? And yeah, it's all a bit fuzzy. We also, since we had these huge hardware problems to start with, we worked basically night shift from day 0 to day 1 and from day 1 to day 2 to get anything at all going. And at least we had our automatic vacuum cleaners going at that time. We had our automatic push-pull switch going. We also had 1 router going. The other had mechanical problems. And at that time, for some reason, several Arduino microcontrollers failed. And then we were left with not enough microcontrollers for all our stations. And it was 2016 all over again. A lot of hardware that was really dear to us and important just died for no reason. So another important fact is we could not count how many capsules we routed because I used the hardware that was meant for the statistics node for something more important. So there's just 3 question marks. I think it must be something around 100 capsules from my guesstimation. Our signaling bus, which is becoming more and more important because we are going to automate the whole network again next time. And this time it was the first real test with many devices on the bus, and it worked kind of well. There were some odd things in the beginning which we were able to fix. And we used about 1 kilometer of cable because everywhere we put a tube, we also needed to put a cable. And luckily we've got these real strong field telephone cables which we can use to tie the tube to the ceiling. So instead of ropes like last year, we could use our cable to tie the tube up, which looks a bit dangerous and not really well thought at first sight, but this cable is really robust and it worked pretty well, so that's fine. Also, it was the first time that we tested this bus with many transceivers that were far apart. So we had up to 400 meters between transceivers, and in the end, it all worked out fine. We even had some of the keypads running. We had some automatic routing running. The automatic routing part was delayed mainly because our network control software couldn't be tested because we couldn't get the hardware on site in time to run some integration tests. And you know how things go. You write a specification, somebody else writes another component for according to that specification, and in the end, everything breaks as soon as you connect it. So we were a bit unlucky this time. So in the end, we made it work for you just in time so that we can tear it down again. And that's an important point. We could use some help tearing everything down, putting everything back into storage. It would be really nice if some of you could spare some time after the closing event to help us tear down. That would be really cool. And also, we would like to improve this because this year's user experience wasn't that good at all. So next year, we want to have everything running smoothly that we planned for this year. We've already distributed the hardware among us, so there won't be the case that just because my packet is late, the whole hardware is missing. And also we need people that can code. We also might appreciate some people that help us with operations next year. So if you want to participate with Seidenstraße, then just try our mailing list, follow us on Twitter, try IRC. We also have a GitHub account with all the code inside it. So if you want to have a look at the code and see if there's something you can improve, take a look there. We really appreciate it. So that's it from my side.
In case you wonder, it seems that neither POG nor CERT are about to speak.